So if degree is 1, degree 0 we said is bad, right? Degree 1. ax1 plus b is integer, right? Is I1. ax2 plus b is integer 2. So a times x2 minus and x1 is not equal to x2, right? Minus x1 is I2 minus I1. So do you agree a is I2 minus I1 over x2 minus x1? So do you agree it's rational? Okay, x2 minus x1 is not 0 because they are not. Now that a is rational, we can say b is equal to I1, x1, x2. Here we're integers. B is I1 minus ax1. I1 integer, x1 integer, a rational, right? So do you agree B is also rational? Okay, now that we found this, we know what? We know P of x is, for example, we can write C over dx plus E over, it's because it is for ourselves, I use same variable. But if you want to write on answer sheet, it's not good to use same variables, okay? Let's also here use another variable, C over dx plus E over f, right? Okay, now, and we know GCD of C and D is equal to GCD of E and F is equal to what?
1.
1. We guess that. So we guess that C should be 1, right? Or negative 1, possibly. So let's see what can we say. It should cover infinitely. It should cover all integers except finite integers, right? Finite 1. So here we can say if C is not 1. Okay. So one thing. Do you agree with the laws of generality? We can consider C over D. C and D are positive because without the loss of generality, we can say C and D are positive integers. Because if it is, why we can say this?
A and D are positive.
Oh, because otherwise it can be negative.
P of x.
Exactly, we can consider negative P of X, right?
What?
And again, when P of X is good, negative P of X is also good, right? So here we can say, for example, C over D plus E over F. So we should say that. So for example, when X is D, can we say X should be multiple of D or not? Let's do something.
X should be.
For example, it is CFX, right? Plus ED over DF, right? Agreed, when we use common denominator, it will be this. Okay. Now we can say what? Do you agree? It is integer for infinitely many of them. When it is integer, what can we say? What divides what?
DF divides. Oh, DF divides C of x with ED. Or
Yes. So let's consider, for example, separate D. D divides fx, right?
right.
And f divides what?
ED. D.
D. So we can conclude here D, for example, is f E, right? So P of x is what? Is Cx over Ft plus E over F, right? Okay. Now, in this case, we can say what? Ft is Cx plus Et. Okay. Then we can say what?
Oh, oh. So CF?
Why?
FT to oh. Oh, sorry. T divides CF.
Yeah. We can say T divides Cx, right? For infinitely many integers, right?
Right.
So we can say, for example, our x's are what? And let me check what is it called. Okay. Mm, here we can work on these things to see which of them works, okay? So try to see what's the relationship between C, E, T, F, and I go and come back in 2 minutes, okay?
Okay.
Okay. So let's do something. Do you agree? We can say P of X is increasing or decreasing.
P of X is increasing.
Why?
Oh, because we said C over D is positive.
Exactly. So do you agree it's like something like this?
Uh-huh.
And do you agree because it says we have finite number of terms that cannot be covered? Do you agree from somewhere we can cover all numbers?
Right.
Okay, so for example, suppose for example, here we can cover all numbers.
Uh,
Y plus 1, y plus 2, right?
uh-huh.
So, let's do something. If we check, let's write it again, C over dx plus E over F. For one of them, it will be y, right? For one x. For example, suppose for x1 or xj, it is y. C over dxj plus 1. Or x, for example, L. It
Uh-huh.
is, let's write 1, 2 again. 3, 4 first. Because we used 1, 3, 4 plus E over F is y plus 1, right?
Mm-hmm.
Then if we subtract,
Uh,
what can we conclude?
oh, C
C over
over
the
D
x4 minus
X
x3 is what?
is 1.
So we can conclude C times x4 minus x3 is D, right? So what can we conclude then?
Oh, um, well, if C is greater than 1, then GCD of C and D will be greater than 1.
Yes, C divides D, but because GCD of C and D is 1, we can conclude what?
C is 1.
Yes, C divides 1, but because C is positive, negative 1, so C is 1, right?
Right.
And okay, so x P of x, now let's continue it, right? P of x is x over d plus minus e over f, plus e over f, right?
Right.
We proved that it is ft, this one is something like that, right? So if we consider, for example, let's see, we proved is x over ft plus e over f, right?
Mhm.
Okay, it should cover all integers from some parts, right?
Right.
So if we use common denominator again, it will be x plus et, right?
Mm-hmm.
Over ft. So why
And
can we say that? Is it okay
t
always? You said what?
t divides x or how to
E divides x. Yes, so we can say something. We can say that, for example, suppose x is t times k, right? So p of tk will be what? Will be k over f plus e over f, right? So k plus e over f. So do you agree it's good? Because you increase k and you can cover all numbers, right?
yeah, okay. Yes. Okay. Uh-huh.
Agreed, we can cover all numbers here. Because k can be any integer, so k plus e can be all integers. Okay, and do you agree we can cover all integers? Because you can cover all multiples of f, so you can cover all integers, right?
Mhm.
So it seems that when we have p of x, it says find what? Let's, it says determine the set of all polynomials p with real coefficients such that these. Okay, so p of x is equal to, now we can say c over d, c over, c was 1 plus minus x over ft plus e over f, right?
Right.
When degree is 1, right?
Okay. Uh-huh.
And we proved that degree of p of x should be odd, right?
Right.
Now, let me tell you a hint for odd numbers.
Mhm.
To use that from somewhere, we should cover all numbers. Why? Again, do you agree when degree of p of x is odd?
Mhm.
We can consider the, without loss of generality, it like opens up. We can consider it is something like this.
Okay.
Agreed?
Mhm.
No, no, no. Some, we can consider it is something like this one, right?
Mhm.
Because if it is not like this, we consider negative if it is something like this, right?
Mhm.
So, do you agree if we cover all integers except finite one? Do you agree from somewhere we should be able to cover all of them?
Right.
So you can say it is y. It is y plus 1. We should cover all integers like this, right?
Mhm.
And by these things, it can help you. Want hint from here or want to try on your own?
I'll try.
Okay, sure. Right.
Could you give hint? I'm not sure.
Okay, sure. So, do you agree we should cover y plus 1 and something like this, all of them?
Right.
So let's see what happens. For example, this y is it is for related to x0, okay?
Mhm.
This y plus 1 is related to what? X1, right? And we shouldn't miss any integer, right, from here. Agree? So, do you agree xi are integers?
Mhm.
And also y is integer, right?
Right.
Also, you can say xi positive integer, but it's not important. From somewhere that are positive. Now, it means what? Maybe x0, x1 are consecutive positive integer, maybe not, right? Maybe we have also other integers between them. Agreed.
Uh-huh.
What do you agree from here? If you consider in this interval, what can we say about p of x plus 1 minus p of x
Has to be
for x greater than equal x0? It has to be less than or equal 1, right? Because maybe these two are consecutive. If these two are not consecutive, means we have some integers between them. So it means like this, right? But it's not correct because it is a polynomial with degree what?
degree greater than odd degree.
Let's write an x and an minus 1 x and minus 1, an minus 2 x and minus 2, a1 x a0, right? And we know an is not 0, right? And n is odd, right?
Mhm.
Let's calculate p of x plus 1 minus p of x, okay? So do you agree it will be an x1, x plus 1 to the n plus an minus 1, x plus 1 to the n minus 1, right?
Right.
Minus an x n minus an minus 2 minus a0, right?
Mhm.
So it will be what then? Coefficient of xn, do you agree? The coefficient of xn will be what?
Oh, coefficient of x will be
X to the n. Coefficient of x to the n
x
is...
0.
Yes. Coefficient of x to the n minus 1 is what?
An times n choose 2 plus an minus 1 times n minus 1 choose 1.
Xn minus 1. An times what? You said?
Oh, sorry, an times n choose 1.
Yes, then what? Only this.
Oh, I think.
An. Do you agree it is not 0?
Right.
Because n is not 0, an also is not 0. So degree, suppose it is a polynomial, right? Degree of qx is what?
Degree of q x is n minus 1.
This is at least what?
At least 2.
Yes, at least 2. Because we can say n at least 3, right? Because we've checked n1, right? Now, do you agree? So here we've concluded what? For x greater than equal x0, for all x greater than equal x0, x is integer, q of x is less than or equal 1, right?
Right.
And do you agree p of it is also positive, right?
Mm-hmm.
Agreed?
Right.
So we can conclude this. Is it possible?
Mm-hmm.
Degree of q of x is at least 2. For x greater than
Right.
equal x0, q of x is between 0 and 1. Is it possible?
Um. Oh. No.
Why not?
Oh, because won't degree of Q of X be even? And so the first term, which will be for large X0, it
Mm-hmm.
will be larger X the second than the other terms.
Mm-hmm.
So if first term increases, then wouldn't Q of X be if wait, yeah, because isn't so if first even if the other terms are like negatives, since the first term will be positive, since yeah, oh, wait, sorry. Is it just that for some x0, first term will be much bigger than other terms, and so even if the other terms are negative and the first term is positive, it's possible to reach value greater than one.
Exactly. We said without loss of generality, for example, an is positive, right?
Mhm.
Because an is positive and this one again is positive, right? So do you agree it is even? So it will be something like this, right? And do you agree it goes to
Right.
infinity?
Mm-hmm.
So do you agree for large x's it cannot be between 0 and 1?
Yeah.
So we proved that for degree 3, degree 5, we don't have any good answer, right?
Mhm.
So we solved the problem. Understood?
Okay.
But let me tell you something. Here, I think they accept. But let's prove why for large x we can say it goes to positive infinity. Okay. Suppose q of x is bm xm plus bm minus one xm minus one. Or let's consider for general and not only even and odd. It is a lemma. Okay. Suppose, for example, q of x is a bm xm plus bm minus 1 xm minus 1, or we can also say, for example, and because q we consider this h of x to b1x b0, and I want to say when x goes to infinity h of x goes to positive infinity or negative infinity, right? Under what case it goes to positive infinity?
Um.
Here suppose bm is non-zero.
Oh, if BM is positive, yeah, BM is positive.
Exactly, if we and it is correct. I don't think you need to prove, but let me just show you how to prove, okay? Because it is basic, and if you want to prove, you also should prove this. They will accept. But let's see if you want to. For example, sometimes maybe you should know this approach, okay? Let me tell you how you want me to tell you the proof of this, or want to prove it on your own.
Could you explain?
Okay, sure. So suppose x is I want to select a large x that this one, for example, be greater than anything that. For example, if I say for large x, h of x will be greater than, for example, x over 2. So it goes to infinity, so this one also goes to infinity, right? So let me tell you how. Do you agree without loss of generality we can consider Bm is positive? Okay. Now, do you agree that I consider I want that this part be so much greater than this, so much greater than this, right? For I want to see x should be how much large, okay?
Sure.
So if I want that Bm over xm be so much larger than Bm minus 1 xm minus 1, it is equivalent that what so much larger than what? X so much larger than what?
X so much larger than BM minus 1 over BM.
Yes. So we can say that, for example, mm, x is equal to x greater than, uh, because we need a, you should use some part of this greater than this, some part of this greater than next term, right? So suppose that, for example, x is greater than m squared. Absolute value or bm minus 1 over bm, right? And also we should use for other things x greater than m squared, bm minus 2 over bm. X greater than m squared, for example, b0 over bm. Let's see this x works or not, right?
Right.
Okay, so h of x is what? Or let's consider instead of m, let's write, for example, w. Okay, w, then we say, okay, w goes to infinity, so we want to see what happens, okay? Okay, so h of x will be what? Let's calculate, for example, what part of this plus what part of this will be positive?
Well, like,
So let's say something like this. Do you agree we can say bmxm plus bm minus 1 xm minus 1, this one over w will be what?
now for W will be BM over W will be
W to the m, okay? So can we say x to the m over w to the m? X over w to the m is greater than yes, but here let's do something. I want to say that do you agree if I say it is greater than m times this? So we consider 1 over m of this for this, 1 over m of this for this, 1 over m of this for this, 1 over m of this. For example, m plus 1 times this. So 1 over m plus 1 time for this one, 1 over m plus 1 for this one, then 1 over m plus 1 will be left, right?
right.
Understood what I want to do?
Oh wait. So
For example, suppose we have 4 terms. If I prove that it is greater than 5 times each of them, so 1 over fifth of that is greater than this. 1 over fifth of that greater, for example, we have 4 terms. Then 4 over fifth will be this. 1 over fifth will be left here that is positive and all of them positive. So it goes to infinity. Understood what I want to do? But with variables. So I want to say what? Let's do something. So much greater than this. I want to say that for what x? It is greater than this one over m plus 1, right? And then do you agree it is equivalent that x greater than bm minus 1 over bm times m plus 1, right?
right.
Then I do same thing for all of them. b0 to bm m plus 1, right?
Mhm.
Now suppose we select, for example, here you consider t1 to tm, right? Or let's consider tm minus 1 with these indices to t0, okay?
Mhm.
Now suppose that x is greater than maximum of t0 to tm minus 1, okay?
Right. Mhm.
Now because of this, I say what? I say h of x is equal to bm xm over m plus 1 for itself, then bm over xm over m plus 1 plus
Mhm.
bm minus 1 xm minus 1, right? So
Right.
let me tell you something. We want to do what? We want to say that this plus this should be positive. Or let me tell you this. I want to select something like this over m plus 1. Agreed?
Mhm.
So it should be negative, right?
Right.
So this one, a negative. Agreed?
Mhm.
So if I write like this, it will be what plus, again, bm xm over m plus 1 plus bm minus 2xm minus 2, right?
Mhm.
Plus 2 bmxm m plus 1 plus b0. This right?
Right.
Do you agree because of these conditions all of them are positive?
Right.
Because we said this one is positive. 1 over m plus 1 of this is positive. We consider 1 over m plus 1 of this for itself, 1 over m plus 1 with next m terms. So do you agree it is h of x and all these terms are positive? And now, do you agree it will be greater than bmxmm plus 1?
Right.
Do you agree for large x it goes to positive infinity?
Uh-huh.
Because bm over m plus 1 is a positive number, positive constant times xm. So x, when
Right.
x is so much large, it goes to infinity. So h of x also goes to infinity.
Right.
Understood?
Wait, the
What?
h of x, the way it, how did you create that h of x?
So h of x is a polynomial, main polynomial.
Okay.
That
Uh-huh.
I want to say if x goes to infinity, h of x goes to infinity for bm positive. Okay. I wanted to say that this one will be so much greater than these things. Okay. For large x. I said okay. For example, if we have 9 terms here, I want to say that here I split this to 10 equal parts, okay?
Okay.
And I want to say, okay, 9 pi parts for these things. For example, 1 over 10 of this plus this positive to 1 over 10 plus this positive. Then 1 over 10 of this is left, which is so much large, right?
Right.
And then we prove that when x goes to infinity, h of x goes to infinity. You don't need to prove this, but I just told you this to see how we can.
Oh, wait, how did we bm x raised to m over m plus 1 plus bm minus 1 x raised to m minus 1 is greater than 0?
Because of this. Do you agree? We said I want to find x's that this one is positive. Do you agree then x is greater than this? Then similarly I define for b0, b1 to this, so t0, t this. If x is greater than this, we have all these conditions. So I said, suppose x is greater than maximum of them to satisfy all these conditions. Understood?
Yeah.
Okay. Any question about this problem?
No, that's good.
Okay. But you don't need, as I said, to prove. Only this part is okay. Okay? Okay, now